Hello and welcome to the Lentigame training presentation on monitoring sample designs. My name is Lindsay Reynolds. I'm a riparian ecologist at the BLM National Operations Center. Sample designs cover how we go from a landscape of resources of interest to data and information about those resources to help inform land management. Important terms in this presentation include the study area, stratification and strata within a given study area, random points, including their fate, sampled, not sampled, reattempt needed or rejected, and targeted points, and the important differences between randomly selected and targeted points and how they can complement each other in a monitoring sample design. What is a sample design? The sample design is the process by which sample sites are selected to represent a study area and meet a monitoring objective. A sample design includes defining monitoring objectives, defining the study area and resources of interest, defining reporting units, identifying stratification if there is any, sample site selection, and then a plan for implementing and managing the sample design. So for a given landscape, how do we understand the resources on that landscape? The study design identifies the study area on that landscape or the boundaries around which we want to sample, and then the sample population inside that given study area. The goal of a sample design is to select an appropriate sample from a resource of interest in order to estimate attributes of that resource in an unbiased and cost-effective manner. Sampling for monitoring natural resources identifies the fact that most of the time we can't measure all of the resource we're interested in. Sampling using measurements from a selected subset to estimate attributes of the entire resource. There are lots of different ways to pick a sample. Sampling and it's statistically valid is statistically valid if it gives an unbiased estimate of the resource of interest. Sample designs may be probabilistic or targeted. Probabilistic are randomly selected sites within a study area and provides inference to the whole study area. In other words, we can draw conclusions and make statements using the data and information from that study area about the whole study area. Targeted sites are manually selected points based on a local management objective, and we cannot make inference beyond those sample points, but they address an immediate and local need for an objective. All sample designs must be objective-driven. They can have short-term objectives such as evaluating treatment effectiveness or for grazing permit renewals, or they can be more long-term in the objectives such as to report sage-grouse habitat conditions to contribute to land use plan effectiveness determinations, or on a landscape scale to address future questions that may at this time be unknown, but having data on landscape scale can help address landscape scale questions. What is a study area? Study area defines the extent of the resources you're interested in. For example, a study area could be all BLM lands in a given field office, or all wetlands within a grazing allotment. It's the maximum area you want to draw conclusions about. In statistical parlance, it's called the population. The target population or the study area is what you want to know about. A sample population is what you can actually get to and sample. Example study areas could be all wetlands on BLM lands in a given state, such as Colorado. It could be all wetlands in a district or field office area, such as Chalice or Salmon field offices. So visually speaking, we have a landscape and we want to draw conclusions or get information about the resources on a given landscape. And this could look like a district in a state such as on this map, the Northwest District of Colorado. Stratification is dividing a population or a study area, such as a landscape, up into subgroups or subunits called strata. This is best done prior to sampling. Stratification done prior to sampling is unbiased. Reasons you might want to stratify include variability in indicators that is different across different types of land, such as forests versus grasslands, and to ensure different types of land or uncommon portions of study area get sampled to deal with differences in land potential. For wetlands, we often stratify by size. In many of our sample designs, we divide wetlands into small, medium, and large wetland categories in order to sample evenly across those different kinds of wetlands. For example, I'm going to show here an illustration of what a sample design can look like. In this example, the study area are all wetlands on BLM lands in the Northwest District of Colorado. Here, I identify that I want 6 sample sites in each of the size strata. So I have 3 size strata, large, medium, and small wetlands. And you can see as the algorithm draws random points how they're distributed across the landscape. So I draw 6 points in the large category, 6 points in the medium category, and 6 points in the small wetland category. So in this case, my study area is the Northwest District of Colorado. My sample design includes 3 strata, large, medium, and small wetlands, and I have 6 sites in each strata. With a sample design such as this example, I can then draw conclusions about each of our sample populations inside of our study area. In other words, what do our data tell us about these wetlands? I'm going to show some example conclusions that one might draw. You might be able to speak to what kinds of wetlands are in your study population. For example, perhaps 75% of all of the large wetlands in our study area are wet meadows. And in this example, average woody height is 2.3 meters, average non-native plant cover is 15%, and average standing water depth is 30 centimeters across these wetlands. Because this is a probabilistic random sample design, I'm able to draw conclusions about our sample population across our study area. An important step in evaluating a probabilistic sample design is to track the fate through site evaluation of each of the randomly selected sites. So what is the fate of each site? And broad categories that are important to document are whether the site gets sampled, whether it's sampled and the plot has been shifted, and if it's not sampled, to carefully document the reason it is not sampled. Please refer to Table 4 on page 27 of the draft Lenticane protocol to see the details of sample site fates. Targeted sites are also an important sample population for monitoring. Targeted sites are informative for land use effects. They address an immediate management concern on the ground. Targeted and statistical sampling can complement each other, and strong monitoring programs often have a mix of both randomly selected and targeted sites. It's important to remember some key things about targeted sites, however. They are targeted to specific land uses or management goals, such as grazing or restoration. The results can't be statistically extrapolated to a larger population, so you can't necessarily draw conclusions about a larger population from these sites. And they can underestimate heterogeneity on a landscape, and they're often sensitive to loss or disturbance. So targeted sites are important for meeting management goals, but we have to keep in mind the statistical implications for targeted sites. In this presentation, I've gone over important terms such as study area, stratification, and strata, random points and their fates, sampled, not sampled, or rejected, and the definition of targeted points and why they're important. This concludes the presentation on monitoring sample designs. Thank you.